number 5, mechanical vibration measurement and control. So I will start with mechanical vibration measurement systems. So basically for mechanical vibration systems, these are the steps of vibrations what you see on the board. But before starting on to the actual measurement process, let me explain you why do we require vibration measurements. So first of all, we know every system has its own natural frequency that is called as omega n. Now, when the system is set into dynamics, okay, it is excited by certain frequency that is this omega. Now, when this omega matches with the omega n, so this is an external thing, this is an inherent property of the system. When this matches out, then there would be a resonance in the system. Once the resonance occurs for the system, what happens is like there would be a catastrophic failure for this particular system. So basically we should know for any of the system what is the natural frequency of the system. Another aspect would be measuring the displacement happening in the system, or what is the amplitude if system is vibrating. So what is its amplitude of vibration? So this particular thing. What is the time period? That is another thing. So basically we have different parameters which we see in vibrations. So the different parameters may be x, x dot, x double dot, omega, fn, time period t. So these are the different parameters, or whatever you want to study, like that particular parameter we should be knowing it. So vibration measurement becomes one of the important aspect for going and doing all the things. Now people may say we find the we can find the natural frequency of the system by taking theoretical concepts. We have theoretical formulas for it. But when we derive this theoretical formula, there are a lot of assumptions. Now, if you see for an example, when we say about a material, we say it's an isotropic material. It's a linear material. So, but in actual case, it may not be. While doing the vibration measurement by theoretical basis, we don't consider any thermal effects out of there. So there are a lot of assumptions which we take into considerations while doing the theoretical or theoretical measurements. So the actual measurements may not vary, may not match out with the theoretical one, but it would vary with that of the theoretical one. So basically, we need a system, or we need a device to measure this one. So either x, x dot, x double dot, f, or so on. Next important aspect is when we look at this particular actual conditions, okay, we know like there are vibrations happening in the system. Now once the vibrations happens in this particular system, then we need to suppress the vibrations. So how to suppress that vibrations is by using vibration isolators. So once you know the different parameters, based on different parameters, what would be the isolator being used, that we will be able to study out. Now, you may have seen this vibration measurement being measured out. Okay, for example, if you have seen an earthquake, okay, what do these people do? Okay, on the earth crust, like they measure the amplitude of vibrations. And one of the sudden, if there are certain peak vibrations happening, okay, they say like, okay, there is certain earthquake happening on the system, on the earth. So this type of systems, okay, are used for vibration measurement. Now, this particular aspect is nothing but the requirement of measurement. So why we require? So these are the terms. Now, once we know that we require certain parameters to be measured, there should be certain steps involved in measuring these processes. So this particular flowchart diagram shows the measurement process. So first let's see, or let's try to understand this particular diagram. So you can see the first component is vibrating machine or a structure. So first of all, you should identify, okay, what machine or what structure or what component we need to measure out. So first is we need to identify the system. Then second is, okay, which parameter we should measure out. Which parameter should we measure out? Whether it's x, whether it's x dot, whether it's x double dot, whether it's frequency. So you should know which parameter of that particular system needs to be measured. So what we do is, like, irrespective of these particular parameters, we will be seeing this in a generic way or a generalized way. So this is a vibrating machine which is going to vibrate out. Next, a vibration transducer or a pickup. Vibration transducer means a device which can measure this particular parameter, whether it's displacement, velocity, acceleration, or frequency. That particular parameter is being measured by certain type of instrument or a pickup that we are going to place on this particular machine or the structure which we want to measure out. Next, what we do is, this particular measurement is actual, or we call it analog. So this analog signal is being, we are going to get it from the machine. Now this is being converted from analog to digital converter. So once this signal is being sent to this signal conversion unit, we can see this measurement on the screen, maybe on a computer screen, maybe on the oscilloscope, or maybe the, like, your mobile device itself. Like you can see, like in mobile device also, like there are certain frequency measurement apps. So you can just see, like, okay, if something is happening in the real world, okay, you're directly getting it on the screen. So it is being happening with this ADC signal, analog to digital converter. So you see that graphs out on the screen. So this is the digital signal. Now, sometimes what happens is, like, we just see this data and this data vanishes out. But for our study purpose, what we do is, like, we try to store this data. So we store this data for future analysis. So if you want to see, when the machine was new, okay, you want to see the data like how it was. Then once the machine gets into workout, okay, then you again plot the data. So this data analysis, this particular thing, like this particular entire thing, would help you out to look at the condition of that particular machine. We are going to look at machine conditioning later in the topic, but for now you just look at, like, what are the steps involved in this measurement process. I hope, like, you understood this. If you don't understand any of the point, like, you can just put it in the comment box and I can reply you back. Next is classification of vibration measurement instrument. So we are going to broadly classify this based on this particular upper tree item. So first is based on the contact between vibrating system and the instruments. So if this is a machine, and if you place the vibrating instrument or the measurement instrument directly onto a machine, it is called as contact time. If you place it away from the machine, but still you are going to measure that particular parameter of the vibration, but this machine and the device, this is the device. So this device are not in contact. So it is called as non-contact type of instrument. So first classification is based on contact types. Second classification is based on the requirement of power. So when I talk about power, it is to be understood that it is about electrical power. So if you require power, it is called as active instrument. If you don't require power no, then it is called as passive instrument. So based on power requirement. Next is based on how you measure it or the method of measurement. So basically, first is indicating type and second is recording type. For indicating type, you may be like whenever you go for filling the air in your vehicle's tire, okay, you see a burden pressure gauge over there. What this pressure gauge is like, it just indicates like what is the pressure. And once it removes, like it goes down. So it is just indicates like at that particular moment what was the pressure. On the similar ways, okay, there are certain instruments in vibration measurement, okay, which just indicates like, okay, this was the peak, this is the thing. So if it's indicating, then it's called as an indicating type of instruments. In some of the measurement instruments, okay, it has indicating as well as recording facilities. So if you have the data which indicates at that particular moment time, and you can record it and save it for the future use, then that type of instruments are called as recording type of instrument. So it is based on the method. So what type of method you use. And the last one is the most important one. So basically based on parameters. So everyone knows this particular equation. So mx double dot plus cx dot plus kx is equal to f0 sine of omega t. So this is an equation for forced damped vibratory system. In this one, mass of the system, damper of the system, spring of the system, and the external excitation will remain constant. What varies out over here is the acceleration, velocity, and the displacement. So x dot, x double dot, and based on this, you can also have omega n, which is under root of k by m for this particular system. So based on this omega, you can find Fn or you can find time period Tn. So these are the different parameters that are mostly studied while doing the vibration analysis. So these are the different parameters, parameter number 1, 2, 3, 4. So if you are measuring the displacement, the amplitude of displacement, then this is called as vibrometer. If you are measuring x dot, that is velocity, then it's a velometer. If you measure the acceleration of the system, it's called an accelerometer. If you are measuring the frequency of the system, it's called as a frequency measurement. So depending upon the parameter you choose for study, okay, that type of instrument is classified accordingly. So I will stop over here. So if you have any question, any queries related to this particular topic, okay, ping me in the comment box or you can call me directly. Thank you.